What's up guys, Amar here from Magic Coding, and in this video we are gonna have our helix rotation Z move to the left or to the right depending on where do we move our mouse when we click on the button. To do so, we're gonna go ahead and open our helix script, delete the touch pressing, it's not needed, and delete the start function with the comments. First, we're gonna have our private boolean movable, so movable, which will be true for now. Later on, we're gonna change it. Then we're gonna have our private float angle, and we're gonna have our private float last delta angle, and we're gonna have our last touch X. Inside of the update function, it's gonna be pretty simple. We're gonna check if we are movable, so if this thing is movable, and we're gonna check if touch dot is pressing, meaning that we are touching with our mouse or with our finger if we are on the mobile device. Then we are gonna check our float mouse X, not check, but we're gonna say that our float mouse X equals to our this dot get mouse X, like this. And what is get mouse X? That will be our private float get mouse X, which will return our input dot mouse position dot X divided by float of our screen dot width. And simple as that, we are done with our get mouse X. I mean, you can even go and copy this and put it in the one line, but I just pretty much like it like this, and I'm not gonna change it. Now we're gonna say that our last delta angle equals to our last touch minus our mouse X, like this. Then we're gonna say that our angle equals to or actually plus equals to our last delta angle. Multiply that by 360, and then you can decide if you want to multiply it again, depending do you want to go faster or slower. Now I want to go, let's say, about 1.7 float, and then we're going to say that our last touch X equals to, so last touch X equals to our mouse X, like this. So before I continue, I'm going to explain this in a second. First, we're getting where is our mouse, so where did we hit it? Then we are setting up that our last delta angle is last touch X minus our minus X, so we get the middle of it. Then we're saying that our angle will equals to our last delta angle, so where we want to go. Multiply that by 360, meaning that we're gonna rotate by 360, and then this is like a speed, so you can do the script without it, and you can go with this. So if you put here, like, let's say 100, it's gonna go pretty fast, and if you put 0.1, it's gonna pretty slow. I decided to put 1.7F because I tested it out and it worked out for me. You can do that by yourself. Then we're gonna check else if our last delta angle is not equal to 0, so if it's not equal to 0, and we have let it go of the button, we're gonna say that our last delta angle minus equals to last delta angle, multiply that by 5 and by time dot delta time. And then we're gonna say that angle plus equals to our last delta angle, multiply, so actually just gonna copy this. And what is this over here? Well, basically, when I let go off of the screen, or I'm not gonna stop my cylinder, like it hits something, but actually it will go slowly slow down and then stop. So that meaning if our last delta is not equal to 0 and we have let it go off of our button, or we're not touching the screen, then we're gonna slowly put it to 0, where we're gonna multiply that with our angle. And now last but not least, we're gonna say that transform dot Euler angles equals to new vector 3, which will be 0, 0, and then our angle. and pretty much that is it. Now let's go back to script, and now let's check the number here on the rotation Z in our helix game object. So if I click, and then I click onto the screen and go to the right, we are rotating to the right. If I go to the left, we are rotating to the left. And you see, it is working. Now what is there to it is actually for us to create a cylinder that will be movable. So go ahead and create a 3D game object, which will be our cylinder. We're going to change its mesh to our model. Let me find the proper model for it. It's the second one, or actually the third. Actually, it's the third one, my bad. We're going to remove the capsule collider. It's not needed. As for the mesh renderer, we're going to change the material to the helix. And we're going to say, so let's reset it to be 0, 0, 0. And this will be 0, 2. As for the Z rotation, we're going to say 2.2. As for the Z scale, it will be 1000. I mean, it's not necessary to have 1000, but we are going to have 1000. You can with any number that's greater than 300. I don't know, maybe about 2 and something. What works for you? And then we're going to create another C# script, which will be called helix and then cylinder. So cylinder. Open that up once our Unity loads it. And there we're going to have one simple line of code, or actually 2, but never mind. First, we're going to check for our for our private game object helix, like this, where we're going to say in our awake that our helix equals to game object.find, and we're searching for the helix, that thing we have. And why awake over the start? Because our start function is slower than awake. If I were to compare awake and start, which I did in previous lessons, you will see that awake goes first. As for the update, we're going to say transform.Euler-Angles equals to new vector 3, which will be 0, then comma 0, then comma, helix dot game object dot transform dot Euler-Angles dot z, and then here on you can choose. I choose to put percentage of 25. This works for me, but it also works if you put divided by 5 or 6 or 25. You can choose whatever, but I recommend to use percentage 25. And why am I saying you can use this, you can use that, you can do whatever, you can make your own game? Well, actually you could, but I'm saying this because you have to realize that all of these numbers that are looking random to you is something that I have tested around, play around to see if it's working. And while you're doing your prototype games, you will have to test things around to see if it's working. You may get something like a little bit buggy or something that you would never imagine before, and you like it. You never seen it before in the game, and you like it, and you can keep it. But you can only do that if you're testing things out. So you can test this thing, test that thing, then you will have better knowledge of it, and so on and so forth. Now, enough of me talking. Let's add our helix cylinder onto our cylinder. So helix cylinder. And one more thing, why are we dividing? Because our helix cylinder has a hole down, as you can see. It's not like as, can I even show it? As you can see here, we have this thing. So it's, if you rotate it by 360, you will get with no space in between. And because of that, we're going to divide it. So let's say it's 360, or actually let's say it's 90, or what number does it have to be? Let's say it's 180, and you divide that by 5, it's never going to go to that side. So no matter how much you rotate it, it will be always onto this side. Now let me start and let me show you what do I mean by that. So right now you can see that when we are moving to the left, it's moving to the left, but just moving. It's not rotating wholly, but it is just kind of moving. It's kind of trippy to explain, but you can see what's going on. I mean, you have eyes. I don't have to talk everything out. So click on it, then go to the right. It's moving to the right. Let's go to the left. It's moving to the left. Right, left, right, left, right, left. and voila, we got it. So yeah guys, that will be it for this video. We made our cylinder move, and into our next video we're probably gonna have our ball moving forward. Until that time, goodbye, and I will see you in the next video.